So this is going to be section 6, and we're going to be proving statements about segments and angles. These are going to be our geometry proofs. So we have basically what we're going to be doing here are the 2-column proofs. However, you could also do a paragraph proof or a flow chart proof, but what we're going to focus on this year in the honors class will be the 2 columns. The first column will have your statements, and the second column will have your reasons. So your proof is a logical argument that shows a statement is true. The reasons are going to be based on definitions, postulates, rules. We're going to be using deductive reasoning to create these proofs. So we're going to be justifying them with known facts. Acceptable reasons in a proof. Like I said before, we're going to be using deductive reasoning. So the given information is either going to be from a statement or from a diagram. And then the reasons to justify those statements will either be definitions, they might be properties, postulates, and theorems. Now, notice here it says previously proven ones. So what this means is I'm not going to expect you to pull a theorem out of chapter 6 when we're doing tonight's homework. Okay, so the theorems that you're going to be using or the postulates are only going to be things that we've learned so far in chapter 1 and the beginning of chapter 2. But as we move along, when we get to chapter 6, chapter 1 is fair game for it. You can go back and use anything you've learned since the beginning of the year. That's going to be the most difficult part about, geometry is you can't forget anything. You got to have like mega space in your brain to remember everything. So you're going to have to remember everything from chapter 1, chapter 2, and so on. Nothing's going to go away. And that'll be the most difficult, challenging part, is trying to recall everything. Everybody good on this slide? Okay, let's look at the next one. Okay, now, these look familiar to you guys? Okay, they're the same ones that we saw with the algebra properties. The only difference now is instead of saying the properties of equality, they're calling these the properties of congruence. Okay, so when we talk about properties of equality, we're like comparing two numbers. Here we could be comparing and showing that two segments are the same size. They're congruent, but we don't need to know their numbers. So these are the same properties, and they're called the properties of congruence. So same property, reflexive, like the mirrored image. You're just now applying it to the segments and the angles. Symmetric property, remember it's like a line of symmetry. So it's like flipped backwards. And then the transitive property, remember the end of the first one matches the beginning of that one. And then you can show that the beginning and the end are congruent. And again, we're applying these to both segments and to angles. Okay, we have a proof. And I don't know if I did this with the girls yesterday or if I did it in class. Did I do this one? Okay, well, let's cover this one. Okay, so they've given us all the statements. Notice that they've given us, we have our given, and they're showing us what we need to prove. Now, sometimes if your picture isn't labeled with the given information, you should always label it. And so that way you can see things a little bit better. Now, notice in the picture, they have labeled angles 1 and 2 with congruency marks. So they have the little red marks here showing that this angle is congruent to this angle. So in statement 1, what is the reason for, or how can we state that? David?
I was going to say the symmetric property, but like you have to do something else though, right?
So for the first one, you mean?
Yeah.
Okay.
It's the symmetric property, but I don't know why.
Okay, not symmetric. What is the first statement always? It's always given. So this one's given to us. And it was given over here. See the red? Given. So this was given. Now, most of the time, you'll probably be given some words describing what's given, and you might also be given a picture. If you're not given a picture, sometimes it'll be helpful if you draw your own picture. Okay, so now we have to look to see what was the next thing that they decided that they needed to start explaining. Now, in the algebra proofs, we have to go chronologically from one step to the next. Now, we don't necessarily have to do something to statement 1. We can somehow incorporate something from our given information or our picture. And that's what they've done in statement 2. They've actually start to bring in what we're trying to prove. So what they've done is they've taken the left side here, the angle EBA, and they're showing you how it's made up. So if I go over to my picture and I highlight EBA, I can see that it's made up of adding angle 2 plus angle 3. So when I take two smaller pieces to make a larger piece, this is called what property? Or postulate, which one? Or definition?
Angle addition.
Okay, good. These are angles. So this would be the angle addition postulate. So angle addition. You can put a plus sign. We can write it like that. Okay, or if you want to write AAP, you can also write that. Now, let's look. Now, in this next statement, we could sort of see there's some similar things there. What do you think they did from statement 2 to 3? What changed? Yes?
They subtract 2 from the 3.
2 from the 3. No? What did they do?
They substituted the 3 for the 1.
Good. They used the substitution property because back in our given, 1 and 3 are equal. So they decided that they were going to take out this 3 and replace it with angle 1. So this would be the substitution property. Okay, now what happened in step 4? Now they're sort of changed their minds now. Now they're talking about the other side. They're talking about DBC. So let's go over to the picture. Let me erase what's in there. And let me highlight DBC. So I have DBC as this big one right here. And it's made up of angle 1 and angle 2. And notice they're showing us that this smaller angle 1 plus smaller angle 2 equals the bigger angle DBC. So this is what? And we can repeat properties over and over again, or postulates or definitions. Valentina. Angle addition postulate again. All right, so the same thing that we did to the left side, that EBA, now we're doing it to the DBC. So angle addition postulate. And now step 5, what did they do? What changed from 4 to 5? Jason.
They substituted the measured angle 1 plus measured angle 2 for the measured angle EBA.
Beautiful. Substitution. So they took out 1 and 2 and replaced it with the EBA. And now that is exactly what we were trying to prove, so we're finished. Your last statement should be what you're trying to prove. Good on that? Okay, anybody still need the slide?
I have a question.
Yes.
Are the statements like for these? Oh,
Example 2, another proof. Okay, again, we have the statements. We must provide the reasons. So we have a given and we have a picture. And then we're showing that we want to prove that AB is equal to BC. So, my first statement, what's it going to be? Given. Okay, we should do this. Okay, the next statement, what's going on there? That AB plus BC equals AC. So they're saying that AB plus BC equals the whole thing. Good. Segment addition postulate. If you want to abbreviate it as SAP, so SAP could represent segment addition postulate. All right, next. What did they do from step 2 to 3, or what's going on here?
substitution.
Substitution. Good. Okay, because what we saw up at the top was AB plus AB equals AC. So what they did was they took this given, and here was AC, and they put it over here. And then this just was here, so it was substitution. Okay, now from step 3 to 4, what did they do?
They subtracted the AB.
Good. They subtracted AB from both sides, so this would be the subtraction property of equality. And again, if you just want to write subtraction, I'm okay with that. Property of equality. You could just write subtract or subtraction. Sort of getting a little better, maybe, not so much. Okay, everybody good on this slide, or we need a few minutes? Yes?
I don't get how the second one is the second.
Okay. Again, we've got our given. It's got what we're trying to prove, and it's actually got a diagram. So it's telling us that M is the midpoint of segment AB. So what's our first reason? Given. Now, in step 2, they're telling us that AM up here is congruent to MB. How do I know that? Okay, so by definition of midpoint, because that was given to us. So the reason for number 2 is definition of midpoint. You don't have to spell it out or tell me what the definition states. Just tell me it's the definition of midpoint. That's how I know those 2 segments are congruent. Now, this next statement is going to be the definition of congruence, because all they've done is gone from the congruent symbol to the equal sign. So you don't need to tell me that if you're writing your own proof, you don't have to include this step. You don't have to show me that congruent angles are equal or congruent segments are equal. So you could skip this step if you were writing your own proof. However, if it was a proof that I gave you the statements, your reasoning would be definition of congruent, I could put a little symbol, segments. So again, remember this thing here is congruent. So this says definition of congruent segments. You could have just skipped that step 3 if you were writing your own proof. All right, for step 4, it's stating that AM plus MB equals AB. So this piece plus this piece equals the whole thing. Michael?
Segment addition.
Yes. So that is the segment addition postulate, SAP. What did they do from step 4 to 5?
Substituted MB for AM.
Good. Substitution. And then the next one, what did they do? From 5 to 6A? They simplified, and that's a reason. So simplify. And then from the final one is going to be, what did they do? They divided or they multiplied, right? They multiplied by the reciprocal or divided by a half. So on that last step, you could either tell me that it was the multiplication property of equality or the division, depending on how you look at it. So 7 would be either multiply or divide, because dividing is by multiplying by the reciprocal. Good on that? Okay, the next slide just basically talks about writing a 2-column proof. So it just says, in a proof, you're going to make one statement at a time until you reach the conclusion. Okay, you're going to, because you make statements based on facts, we're using deductive reasoning to create this proof. Usually, the first statement will be the given, and that would be your reason. Okay, if you're not given a picture, draw a picture. If your pictures aren't labeled with congruency marks, put those in there and add your congruency marks so you can have a better visual of what's happening. So again, your statements over here in this column are going to be based on facts or conclusions that you could make based on deductive reasoning. The reasons are always going to be definitions, postulates, proven theorems, anything that we've learned up into the point where we are doing these proofs. So for us right now, it's only the information in chapters 1 and 2. Okay? Your last statement should be what you're trying to prove, and you must justify that with a reason. Everybody good on this? Did you guys have to fill anything on here? Yes. Alexa. Okay, so this is our given information. I provided a picture for you. And we need to try to prove that the measure of angle 2 equals 118 degrees. What should be our first statement? We're going to try and do this on our own.
And measure of angle 1 plus the measure of angle 2 equals 180.
Good. And we could also include the measure of angle 1 equals 62. We can actually put that all together for statement 1. If you want to make it 2 separate statements, you can, but you could put all your given information in one statement. Okay, now, what do we want to try to do next?
Substitute angle 1.
Okay, good. We're going to take angle 1 out of this first statement and put in 62. Beautiful. So I'm going to put 62 plus the measure of angle 2 equals 180 degrees, and the reason is substitution. Perfect. All right. I still need to show that angle 2 equals 118. What can I do next, Valentina?
You put the measure of angle 2 equals 118.
Good.
The reason would be subtraction.
Beautiful. So what I have to do is, I'll just show that what we did was minus 62 from both sides, and that's how it canceled, and we were left with the measure of angle 2 equals 118, and we're done. So here is another example of a geometry proof where we knew that they were supplementary angles. We knew one of them, and to solve that, you knew you had to subtract. So, and we just have to write it out.